Hi everyone. In this video, we're going to go over proportional and non-proportional relationships. This is lesson 3.5 in your textbook. We're going to start with what represents a proportional relationship. A proportional relationship can be represented using this equation, y equals kx, where k is called the constant ratio or the constant of proportionality. The graph of y equals kx will always be a straight line that goes through the origin 0, 0. So let's look at this example of a proportional relationship given in the form of an equation, in the form of a table, and in the form of a line. Let's look at the relationship between all three. All right, so let's say we replace x here with 0. You replace x with 0. 3 times 0 is 0. That means y is 0. Let's say we replace x with 2. 3 times 2 is 6. That means y is 6. If we replace x with 4, 3 times 4 gives us 12. That means our y value is 12. If we replace x with 6, 3 times 6 is 18. That means our y value is 18. If we replace x with 8, 3 times 8, we replace it with 8. 3 times 8 is 24. That means our y value is 24. So that's the relationship between this equation and the table. Now let's say we want to take this table and graph it. Using a graph, we're going to plot these points. Okay, 0, 0 is located right here. 2, 6 is rated 2, 6 is located right 2 up 6. 4, 12 is located 4 right up 12. 6, 18 is located 6 to the right up 18. And 8, 24 is located 8 to the right up 24. And then when you connect these points, you get a straight line that goes through the origin. This relationship here is a proportional one because it's a straight line that goes through the origin 0, 0. Okay, so this is a proportional relationship because it's a straight line and it goes through 0, 0. All right, let's look at some more examples. Find the k for the following proportional relationships. So all these equations right here are proportional relationships. And we are asked to find the constant ratio k. So in this case, k is this number here in front of x. So k is 8. All right, in this equation, it's the number again in front of x. K is 1/5. See if you can find the k value for the next one. K is, you said -6, you are right. All right, let's keep going. Determine if each table represents a proportional relationship. If it does, write the equation that represents it. All right, so to determine if it's a proportional relationship, all you have to do is divide y by x and see if you get a constant value, if you get a constant ratio. Let's try that. 10 divided by 2 is 5. What about 15 divided by 3? That's also 5. What about 20 divided by 4? That's also 5. So every time I divide, I get k equals 5. So my constant ratio for this relationship is 5. So now I can write the equation that goes with this relationship. We'll start with y equals kx, because that's the equation of a proportional relationship. And then we'll come back and replace k with 5 to represent this relationship. So it'll be 5x. And that's it. All right, let's try the next one. 10 divided by 2 is 5. Okay, this one is the same thing. This one's a repeat. Let's skip that. 7 divided by 2 is 3.5. Is 3.5. 9 divided by 3 is 3. Okay, these are not equal. We don't get the same thing. So this is not proportional. Okay, no, this one is not proportional. Not proportional. I'll just abbreviate. Let's try the next one. Negative 8 divided by 2. Again, it's always y divided by x. That gives us negative 4. Negative 12 divided by 3 also gives us negative 4. And negative 16 divided by 4 also gives us negative 4. So this one here is a proportional relationship of the form y equals negative 4x, because negative 4 is the k value. All right, let's try this one here. 4 divided by 1 is 4. 7 divided by 2 is 3.5. All right, I already know. And 10 divided by 3 is going to give me 3 1/3. So I don't get a constant value here. This is not proportional. Not proportional. Determine if the relationship represents a proportional or non-proportional relationship. The cost of tickets to a show is $20 each. Well, you can actually use a table to make more sense of that. X, Y. If you buy one ticket, it's $20. If you buy 2 tickets, it's $40. If you buy 3 tickets, it's $60. So 20 divided by 1 is 20. 40 divided by 2 is 20, and 60 divided by 3 is 20. So this is proportional of the form y equals 20x. Okay, so this table can be represented using this equation. All right, let's do the next one. One candy bar costs $2. Let's use a table to represent this. X is the number of candy bars, Y is the cost. So if we buy one candy bar, that'll cost us $2. If we buy 2 candy bars, that'll cost us $4. If we buy 3 times 2, that'll cost us $6. So let's see, 2 divided by 1 is $2. 4 divided by 2 is $2. 6 divided by 3 is $2. Do you see every time we divide y by x, we get $2? So in this case, k is 2. So our equation is going to be y equals 2x. All right, let's go to number 11. The cost for each pizza is $10 plus delivery fee. So x, y. This represents the number of pizza. This is going to be the cost. So if we buy one pizza, it's going to cost us $10 plus $5 delivery. That's going to be $15. If we buy 2 pizzas, it's going to be $20, 10 plus 10, $20 plus $5 delivery, it's going to be $25. If we buy 3 pizzas, it's going to cost $30 plus 5, it's going to be $35. Now, 15 divided by 1 is 15. 25 divided by 2 is 1250. Okay, do you see this is not going to give us a proportional relationship, because every time we divide y by x, we get something different. Okay, so this is not proportional. All right, let's keep going. The cost for a gym membership is $25 each month plus $50 application fee. Let's use a table to help us. So this is the number of months. If we go 1 month, it's going to cost us $25 plus the $50 application fee, that's $75. If we go 2 months, that's 25 plus 25, that's $50 plus the application fee, that's $100. If we go 3 months, that's $75 plus 50, that's $125 for 3 months. So 1 month cost us $75. 2 months cost us $100. Do you see 100 divided by 2? It's going to be $50. 75 divided by 1 is $75. Okay, do you see that we don't have a constant value here, a constant ratio? It's not the same each time, so not proportional. All right, the cost to rent the car is $20 a day plus 25 cents each mile. All right, let's just reflect. Each time we were given one cost without an additional fee, like in 9 and 10, we were given one cost and no additional fee. One cost and no additional fee. We ended up with a proportional relationship. But when we were given a cost plus a fee, here we ended up with no relationship. We ended up with not a proportional relationship. Again, we were given a cost and a fee here, and we ended up with not a proportional relationship. Do you think this is going to be the same because we have $20 here, and on top of that, we have an additional fee of 25 cents each mile? Do you think in this case it will not be proportional also? Okay, let's use a table to make this a little bit more clear. X is the number of miles and Y. So if you go 1 mile, it's going to cost you $20 plus 25 cents for that 1 mile. So $20.25. If you go 2 miles, it's going to cost you $20 plus 25 cents and 25 cents. That's going to be $20.50. If we take 20.25, divide that by 1, that's going to give us 25.25. If we take $20.50, divide that by 2, that's going to give us $10.25. Do you see that we don't get a constant value when we take y divide by x, y divide by x? So we were right when we said it is not proportional. All right, let's keep going. All right, the next thing we're going to do is compare proportional relationships. I'm going to skip all the way down to this one right here. All right, so we have 3 different situations here, and each relationship is represented differently. Here it's represented in the form of a table. Here is represented in the form of a graph, and here is represented in the form of an equation, C equals 28T. And basically all we're doing is trying to determine the K value and see how they compare. So looking at this one right here, 18 is our X value. This is our X value. Let's start looking at the table first. So this represents your rental cost, which means this is your Y value. It's your dependent value. Time will always be your X value, your independent value. So if you take Y and divide that by 18 divided by 1/2, or let's say 0.5, it's the same thing, you're going to get 36. If we take 27 and divide it by if we take 27, divide it by 3/4 or 0.75, we will get 36 again. And if we take 36 from here and divide it by 1, we're going to get 36. So each time we take the Y value, divide it by the X, we get 36, okay, for this table here. So this table has a K value, or constant ratio, of 36. Let's look at this one here. So we don't have a table, we have a graph, but we can use this graph to help us put together a table. All right, so we have x equals 2, y equals 50 here. So when x is 2, y is 50. When x is 3, y is 75. So let's see, 50, y divided by x, 50 divided by 2 will give us 25. 75 divided by 3 will give us 25. So this one has a k value of 25. This one has a k value of 36. And this one has a k value of 28. Okay? So this one here has the greatest constant ratio. And if we ordered them, it would be from least to greatest. This would be the greatest, then this would be next, and this would be the last one. And if we so if we compared the three, this one here has the greatest constant ratio. This one here basically will cost the most. All right, so what I would like for us to do here is just to interpret what this graph here says. Okay, so let's read the vertical axis and see what it represents. The number of cups of sugar. Okay, the x-axis is the number of jam jars. So if you want to make 2 jam jars, you're going to need 1 cup of sugar. If you're going to make 4 jam jars, you're going to need 2 cups of sugar. If you make 6 jam jars, you're going to need 3 cups of sugar. So that's how you would read it. If you are going to make 4 jam jars, you're going to need 4 cups of sugar. What if you made 10 jam jars? How many cups of sugar will you need? If you said 5, you are right. Okay? And this concludes this lesson on proportional relationships.